Hello and welcome back to another video of the K40 cheap Chinese laser system. I think I said in my last video I've been having a blast using this. I haven't had any issues really. It's been really good at accomplishing what I want it to. I know its limitations, and I have those in mind every time I go to do a job, and it's been going really good. I kind of wanted to get into today's video in regards to maintenance of the laser system. So it comes with an acrylic window, and cleaning that, you want to be really careful. You do not want to use any alcohol-based mixture to clean that. Basically what that will do, it will eventually cause it to crack. It'll dry it out and crack it, and it won't be any good to you at that point. So nothing like Windex, anything that's alcohol based, you do not want to use anything like that on the window. What you can use is what's called naphtha, a naphtha thinner. It will not damage the window. When using it on this, I would try it first, like in a corner, just to make sure that it doesn't do anything. But naphtha will not damage most of these acrylics, and it should be good. It's kind of difficult to clean with because it wants to leave a little bit of a residue, but if you do it with just enough on there, it won't cause a problem, and you can kind of figure that out as you go. The other thing is the optics. There's a lot of people that describe how they clean them, and that they clean them every single day. My thoughts on that, and I've got a lot of experience with this, is that the optics, whenever you clean them, you're going to damage them. They're going to get little scratches every time you clean them. So the rule of thumb that I use is inspect them every day, but don't necessarily clean them every day. Inspect them, and if you see anything on them that you think might burn, leave a residue, cause damage to it, just blow it off with canned air. Or if you have a compressor, blow off anything off the optics. But just remember that whenever you clean, you're going to scratch the optics, and you don't want to be blowing through a bunch of optics. Another thing is that when you do clean the optics, you don't use regular alcohol. Get yourself some lens cleaner that's specifically designed for optics. They're not that expensive. They look like this. It's an industrial optical cleaner, and the reason why it's good to use that is because it doesn't have as much impurity in it as regular alcohol would. So get yourself a good optical cleaner or optics cleaner, and also an optics rag or cloth, and when you do clean them, don't go around in circles cleaning it off like that, because all you're doing is dragging whatever's on there all around the surface, which is going to scratch it. So my take on that is to put a little alcohol, maybe a drop on the optic, and kind of move it around on the surface of it, and then take your cloth and just wipe down once, and try and remove your optic cleaner in one sweep and be done with it. Because like I say, either way, it's damaging your optics, but one way will make your optic last longer. If you ever have to do a beam alignment, you know that you have to use tape in order to see where the beam is hitting. Well, you do not want to put tape directly on the optics. I have a 3D printed method of doing this, where it is a holder that holds the tape instead of the mirror holding the tape, and it sits right in front of the mirror, and it works a lot better, and keeps your mirror safe because it won't go through, and it'll protect your optics a lot better. One thing I did notice on this system was that my beam was hitting high on this mirror, and it was okay on this mirror, but on this mirror it was high, and it was kind of coming off to the side a little bit. And I had 3D printed a cone, an air assist cone, and the air assist cone, was the beam wasn't coming straight through, so obviously it was hitting the cone. And fortunately I didn't run it that way. I checked it and noticed that it was coming out the side. So even though the beam alignment was acceptable as far as being on top of itself, it was a little bit too high. So I actually had to do an adjustment on the laser tube in the back, and I had to actually lift it. I had to put some shim, some felty soft plastic material shim, just to lift up the laser so that I could get it to come into the center here. So I kind of got sidetracked there. I was actually hitting low on the mirror, and it needed to come up to be in the center. So I had to lift up the whole back, the whole laser in the back. So if you have to do that, it's kind of an involved operation to do. But now my beam is centered, and it's coming through, and I've got a real nice tight spot, and that comes through in my engraving really well. So but it's always good to at least check your alignment, because if you're having problems with engraving, there really is a lot that can go wrong all along that whole path, including the beam, the shape of the beam coming out of the laser tube. So if you have a bad laser tube, your your spot will be kind of oval, and not round, and that that can be a problem. You could have what I would term as remnant fire. You have a little spray of the laser beam that's not generating in the center. It's not focusing a dot right in the center. So you know, that would require a laser tube replacement in order to remedy that that spot. The other thing is the convergence of the beam. When it comes out, it's a little bit bigger, and then as it goes along, it kind of tightens up a little bit. But if your convergence doesn't tighten up soon enough, then you can get a big spot and get poor engraving. So, but you really can't do anything unless you're noticing, or shouldn't do anything unless you're noticing something in your engraving that's not right. But a lot of that is technical jargon. But if you have any problems with your engraving quality, it could be something like that, which would show up when you do a beam alignment, because you'll not only see your one spot in the middle, but you might see another tiny little spot off to the side, or your beam spot might be oval or something like that. So something to keep in mind. Keeping your rails, the path where the bearings ride, you want to keep those clean, and that seems to be pretty good. You want to keep the top of this clean if you can, because it's just riding on a little Teflon thing there, lobe. And yeah, so that's basically what is going on with the laser tube. These are problems that can exist. But you know, as far as your optics, again, please take that to heart, that you want to make sure that your optics are clean, but not necessarily wiping them every single day. You know, I personally don't recommend it. Others might disagree with me, but I don't see a need, and never have seen a need to wipe those down every single day. You know, a can of air can do wonders for cleaning. So, but yeah, that's basically all I can tell you as far as that. Make sure that your bearings are clean. Just get yourself a rag and put it on there and move it side to side like that, and clean it, and your bearings should last you quite a while. You don't have much as far as bearings at all on this side, so just keeping your rails clean. I haven't done that great of a job myself, but in my defense, I just used it, so it's a little bit dirty from that. But if you have somebody else running your machine, make sure that they just look at those optics every single day. Not necessarily clean them, but look at them and make sure that there's nothing on them. I think that I'm going to stop the video there, and I think in our next video I'm going to go into the lens a little bit, and the focus point, and then maybe after that we'll be ready for some application stuff. But I kind of wanted in these first videos just to kind of go over some of the different things that you want to look after ahead of time before you actually get into the engraving. So when you get this machine, you know exactly what needs to be done ahead of time. If you're planning on a different table setup, having that in mind ahead of time, you know what you're going to do. Because when you remove the table that comes with it, all you're left with is a big cavity. So you want to have a plan as far as what you're going to do with that. But yeah, I think I'll go ahead and stop the video there. So I appreciate everybody who finds this channel, and would appreciate a like and a subscribe. And I will see you on the next video. Thank you. Bye-bye.